Hi, welcome to my channel. Let's continue the 2013 MIT Integration Bee. Today is the part 4 of this series of videos. We will work on problem 16 to problem 20. If you missed the part 1 to part 3, you can click here or click the link in the description box under this video. Now let's look at problem 16. So we need to deal with the product of cosine x and cotangent x for this integral. So first, by definition, we write the cotangent x as cosine x divided by sine x. And then we got cosine square over sine x. Next, we write the cosine x square as 1 minus sine square by using the trigonometry identity. So we can make the division and we got here. Then we split it into two terms. The last term is easy to deal with, and we focus on the first term. Let's define the first term as the capital A. To solve this integral, we need to play some tricks. First, let x equals to 2 theta. So the sine x equal to sine 2 theta. Then we use the double angle formula for the sine 2 theta. So the sine x can be written as 2 times sine theta cosine theta. Next, we use a trick for the numerator to write the number 1 as sine square plus cosine square. In this way, we can do the division and we got two terms. And then we will solve these two integrals separately. So here I copy the results from the last slide. For the red part, we use a substitution and let u equal to cosine theta. So du equals to minus sine theta d theta. Plug in and we got an integral respect to u. For the blue part, we define t equals to sine theta, so dt equal to cosine theta d theta. Again, plug in, we got an integral respect to t. So we got these two simple integrals, and the result is minus log u plus log t. Next, we put back the substitution. Then we replace the theta by x over 2. So we got the result for the capital A. Then we plug in the a into the original equation. So here is the final answer. Now let's look at problem 17. So in this problem, we need to deal with two log functions. And for the first one, it's easy because we can use the integral by part. So we focus on the second term, the log x squared term. So for this term, again, we use the integral by part. So we got here. Note that for the d log squared term, after we do the derivative, we got 2 log x times 1 over x dx. Then we replace this d log squared term by the right hand side inside this box. And we got here. And the x cancel out. So we got here. If we look at the terms colored in green, they are exactly what we are solving for. So we move them into one side. Then we immediately got the result. Now let's look at problem 18. So we need to deal with a fraction here. Since the numerator is x cubed, the power index is odd, so we use a substitution to solve this problem. First, we write into this way. Then we let u equals to 1 plus x squared. So du equals to 2x dx. And x dx equal to half du. So we plug in and we got this expression. Next, we do the division. And we split it into two parts. Integrated and we got here. Finally, replace u by 1 plus x squared. So we got the answer. And note that here the absolute value can be taken off, so we just use the parentheses here, because 1 plus x squared is always positive. Here is problem 19. Again, we need to deal with a fraction here. So first we deal with the denominator. We can rewrite 2 as 1 plus 1. And then we can complete the square for the denominator. So we got here. Then we use the substitution. Let u equals to x minus 1. So we got an integral respect to u. And the antiderivative is arctangent u. And then we replace u by x minus 1, so we got here. And note that arctangent theta is odd function, so arctangent minus theta equals to minus arctangent theta. So the result can also be written in this way. But I prefer to choose the first one to keep it short. Now let's look at problem 20. So for this integral, we have sin x inside the natural log. So our plan is to make the sin x out of the natural log. So we choose to do the integral by part. And note that the red color, sin x dx, can be written as minus d cosine x. So we got here. Then we are ready to do the integral by part. And we got here. Next, we calculate this term in green. So the d log sin x equals to cosine x divided by sin x, then dx. And then we write the cosine x over sin x as cotangent x. So we got this purple term. Next, we need to solve this purple term. And if you still remember, in the problem 16, we have done this integral. And here is the result for this purple term. Then we just directly plug in, so we got here. And here is our final answer. But note that for these two terms in the red box, they can be further simplified into natural log tangent half x. That's all for today. I will cover the problem 21 to problem 25 in the next video. Thank you for watching. Please subscribe my channel if you like it.